Great to be here, thanks. So this is an infrastructure talk. I'll talk about Rollups. Just a couple of words about myself before we get started. So I run the research team at Meta Labs, ZK Sync. I'm also a professor at Imperial College London, teaching computer science. So for the past couple of decades, I've been working on the intersection of programming languages and security. And so lately, the last 4 or 5 years, it's been blockchain-related topics, things related to DeFi, fee mechanisms, effectiveness of audits, analysis tools, things of that sort. Okay, so for this talk, the TLDR is fairly simple. So I'll talk about some of the latest developments in the rollup space, and I think there's been quite a lot, but at the same time, it feels like we still have a number of open questions, things we don't really have much consensus about when it comes to rollup design, and I'll talk about some of that in the next 15 minutes or so. So a few things to get us started. First of all, especially given the market phase that we're in, there's been quite a lot of consolidation around Ethereum in the blockchain space, and despite some of the sort of disadvantages of Ethereum, despite some of the concerns around things like high fees and things of that sort, the roadmap of Ethereum has resonated with a number of people. And so as a result of that, people have gravitated towards Rollup as the execution layer, de facto execution layer when it comes to Ethereum. And some of the reasons sort of behind that are things like open standards, community participation, sort of good positive forces of that sort that drive people towards Ethereum. So that's sort of one thing. The other thing is that EVM compatibility has become a much stronger sort of de facto standard as well. And that's not necessarily because EVM is sort of the greatest VM in the world, hardly. That is the case. There are a number of well-known shortcomings to the EVM, but at the same time, there is a number of, growing number of developers who know how to write Solidity code, Viper code, things of that sort. And so the plan that Ethereum has put forward when it comes to scaling itself, it's up as a chain, which involves rollup, is now seemingly actually taking hold. So when it comes to rollups, you probably have seen some of these things before, but people typically distinguish between two types of rollups, generally speaking. So optimistic rollups, and some examples of that are projects like Optimism and Arbitrum, as well as Zero Knowledge, ZK Sync, which is us, Polygon, Scroll, Starkware, as well as a few others. So in the first case, people rely on fraud proofs. In the second case, people rely on zero knowledge or validity proof-based rollups. And we are in the second camp, but I'll try to give you a relatively unbiased kind of summary of things, if you will. So that's the one point. The other thing is that there is also a degree of modularity that's also settling in this space, which is to say, in addition to the execution layer itself, there are various other bits and pieces that are emerging. So people are proposing approaches to shared sequencing as part of the rollup landscape. People are also proposing approaches to sort of shared data availability solutions. And some examples of that are projects like EigenDA, for instance, as well as Celestia. Maybe you'll see some examples of that in later slides as well. So the ecosystem is growing, in other words. And this is also supported by some of the numbers. So there's this website called L2Beat, and then if you go and look at the numbers over the last year or so, give or take, you'll see that there is quite a lot of growth by at least a couple of metrics. And the first one is basically transaction volume. This is the upper portion of the slide that's been growing quite steadily compared to mainnet traffic. And this is an aggregation of all the rollups that have been deployed over the last year, and their number has been growing, of course, as well. So consequently, we see a lot more traffic. And this factor over here, the scaling factor, 5x or so, is like how much more is actually getting now settled on rollups, how many more transactions are getting settled on rollups compared to mainnet. And chances are that number will only keep growing, right? So that means that the demand for rollups will keep increasing and so on and so forth. And the second metric at the bottom of the slide is the TVL, and this is arguably maybe not the best metric and one that, you know, not everybody necessarily relies on, but, you know, I think it's still useful as a sort of baseline, as something to compare to, because you, again, over the last year or so, you see quite a lot of growth in the rollup space, essentially users coming into this, and the interest is growing and increasing and so on and so forth. So for the rest of this presentation, I was hoping to hit quite a number of topics, so I'll go pretty fast and try to at least mention pretty much all of these points that I have over here. So it's a bit of a list, and there's a bit of a focus as well on the zero-knowledge side of the rollup sort of space as well. So let's start with decentralization, right? So that's one of the reasons we're in this space in the first place. And at the same time, if you look at the de facto deployment of current rollups, they're mostly centralized. There are a couple of small exceptions, but for the most part, while we are on the path of progressive decentralization, at the moment we're still relatively centralized. And so, of course, the question is, well, how do we progressively decentralize while retaining most of the benefits? And the benefits are throughput and latency that the centralized solution genuinely will give us, maybe not the highest level of availability, but at the same time, how do we move towards decentralization without losing sort of the upside that we actually wanted to preserve? And so you can also ask somewhat more philosophical questions like, well, how much decentralization is actually good enough? Like, what's the right number, or how do we measure this, right? So one simplistic way to look at it is to say, like, let's look at Ethereum itself, right, the mainnet. So if you look at the number of validators, the number of validators on Ethereum at this point is actually quite staggering. It's gotten to something like 900K nodes or so. So, well, is that necessary? Is that good enough, right? Like, what is the right number? So is 100 nodes, which is typical, for example, if you deploy a Tendermint-based chain, is that also decentralized? Is it not enough to have 10 nodes? Is it actually necessary to try and climb, you know, to these kinds of staggering numbers? And I think some of these answers are somewhat elusive. By the way, there are some academic papers sort of focusing on these subjects, and if you are interested in that, just kind of go and follow up on what's at the bottom of this slide. So here's another way to look at it. So there is a project called Project Sunshine that looks at Ethereum's decentralization and measures it across a range of different dimensions, tries to be a lot more comprehensive just than, you know, the sheer number of nodes. And you can look at things like the consensus client diversity, execution client diversity, things like, you know, geolocation, right, geo-decentralization, things of that sort. And so this is Ethereum itself. And so even Ethereum itself is not actually all that geo-distributed perhaps as these people would like it to be, let's say, right? So the question is, how do we actually get, you know, an increase on these metrics without necessarily having that high number of nodes, which almost necessarily means that we, for example, reduce our latency, or rather increase our latency. And this is you know, just the decentralization point. If we sort of look at decentralization not only from the standpoint of censorship resistance, but also like high availability, I mean, is there a chance to actually create rollups that give us the kind of reliability numbers or high availability numbers that are common in Web 2 systems, right? So people talk about 5 nines in systems that are built on top of the cloud, for instance. So is that actually in the cards? Is that viable? And if so, is that viable if you allow for permissionless participation, right? So decentralized does not necessarily mean permissionless in all cases. And so does it have to be permissionless? And then there is another paper that talks about some of these decentralization measurements at the bottom of the slide as well. Sequencers, so let's switch over to that. So people, you know, have spent quite a lot of time working on sequencer designs, right? Essentially ordering transactions that come into the rollup, and there are interesting sort of interactions between sequencers and minor extractable values, MEV, and people focus both on preventing the MEV as well as embracing the MEV. And I probably don't have too much time to talk about that, but at the same time, like from a practical standpoint, we haven't really seen all that much deployed out of the academic or semi-academic proposals that have emerged. So far, it seems like the default is to mostly embrace the MEV that's there on mainnet and sort of go with the program, so to speak, at least for the layer 2, and maybe the situation will be a little bit different when it comes to hyperchains or layer 3s, they're called. There are, of course, approaches that are there on baseline Ethereums related to what's called PBS or ePBS that attempt to decentralize things further. There are other approaches that relate to sort of making the operations of relays like flashbots more transparent by adding support for things like SGX and so on and so forth. And the question is, well, should we basically do the same on the rollup, or should we, try to invent something else? Yeah, and so these are some of the questions I think I already posed, so let me just continue. So the other thing that's different in our system, at least when it comes to zero knowledge, is that we, in addition to sequencers, we also have provers, right? And that's where actually a lot of the heavy lifting goes. The majority of the heavy lifting goes into the prover. And so, there's a bunch of novel designs that people are looking at that look at increasing the speed of rather proof production, reducing hardware requirements, coming up with more interesting novel hardware, increasing the parallelism. So there's a number of proposal as well as experimental design, as well as people designing fancy hardware. We recently released a new proof system called Bootjum for ZK Sync, and the goal here is to allow for proof production on much smaller machines such as laptops, and we hope that this will take hold and allow people to experiment with this a lot more aggressively than they have been able to thus far. But I think there is a long-term question in terms of we have so much progress on the prover side, so many people working on new proof systems at the same time, a number of companies such as the ones shown on the right-hand side of this slide, trying to produce hardware, and what is the right software hardware co-design, what is the right sort of mix, and what kind of long-term outcomes can we hope will take place, and why, if we are starting to rely on custom design hardware, is it not going to be a winner-take-all kind of outcome that the way we've seen it in some other domains that rely on ASICs, some of that we've seen in Bitcoin mining as well. So in other words, how do we basically make the prover network decentralized? And there have been some number of designs that focus on that. So far, this is still very early on, and it's really quite hard to tell what's going to be sort of the default, if anything. Yeah, so I mentioned this before. So basically, how do we avoid a winner-take-all possibility? How do we basically have flexible pricing? How do we make sure that proof markets remain reasonably decentralized? And what's the right notion of fairness? These are some of the open questions. And then when it comes to tokenomics as well, right? So we've seen a number of designs that have emerged in the last 3 to 4 years, which basically connect a POS-based system to stake-based governance and stake-based protocol participation, which is all good and well. But I think that's not necessarily the best design for all rollups, especially zero-knowledge-based rollups. When it comes to governance, I think this leaves a bunch of open questions. We haven't really seen that many kind of successful governance schemes that rely on that provide rather L1 governance or L2 governance just yet. So we have to worry about governance takeover attacks. And so in a sense, I think the simple designs that we've seen proposed, I'm not sure that that's gonna necessarily stand the test of time. So how do you create aligned incentives, right? So what are the outcomes we want? So one of the things we want is speed, which means low latency, high throughput. We want to provide some measure of censorship resistance, maybe reduction in MEV, as I kind of mentioned before, high network availability. And so how do we basically provide these kinds of quality with proper token designs, right? How do we provide aligned incentives here? So how do we, also if we are in the race to the bottom when it comes to fees, how do we make sure that there's actually innovation happening and people who provide provers, both software as well as hardware, are actually benefiting from this kind of thing. while at the same time maintaining low latency and relatively low cost. And the other thing is that this is sort of a comment when it comes to designing complex distributed systems. I mean, zero-knowledge rollups, people say it's just math, but the reality is that it's a lot more complex than that, because you have ultimately complex systems that are being, that are sort of in daily operation, right? And so you have to still worry about all the usual concerns: availability, implementation bugs, recovery, infrastructure vulnerabilities, and so on and so forth. And so, it helps to focus on things like reducing the trusted computing base, for example, when it comes to building systems like that, and not just looking at them as just math, effectively. So specifically, people have focused on some bugs that have emerged in the last, even 6 months to a year when it comes to zero-knowledge proof production. So there are several projects that focus on, for example, finding missing constraints in zero-knowledge proofs, and there are some tools that people have put together in the last, several months alone. There are specific projects that rely on zero-knowledge, like, for example, Penumbra, as well as a number of zero-knowledge ZK EVMs that have gone through comprehensive audits, and some interesting bugs have been identified as well. So the night is still young, in other words. I mean, we don't quite know as a community how to build the system at the level of robustness that we ultimately require. Yeah, so when it comes to complex circuit generation, like, how do we get things right? That's sort of the question. And then last but not least is the question of privacy. By and large, modern rollups are considered to be sort of an acceleration facility, if you will, right? So basically something that does execution on the side of chain without too much regard for privacy, although there are some exceptions. There is the AdStack rollup that focuses on privacy first and foremost, but then there are also sort of a number of other solutions and designs, and some of them apply to the layer 1, so they run on mainnet, projects like, for example, Railgun, as well as Cape from Espresso Systems. And so the question is, well, what do we do about that? So do we basically take those projects and just superimpose them on the layer 2 and leave it as is, or do we do something special at the level of the rollup itself? And I think when it comes to the rollup itself, especially if proof production becomes a bit more affordable, then I think there is quite a lot of room for interesting client-side computation, and we are just kind of on the precipice of some of that. We haven't quite explored these possibilities just yet, and if the fees remain relatively low, then this combination of client-side computation combined with low fees is actually a very interesting mixture. So just to summarize, I've touched on a bunch of topics related to rollup design, and as I mentioned in the beginning of this talk, we know how to do certain things pretty well. We've deployed a number of rollups, so ZK Sync Era has been operational for a number of months now with a growing transaction volume, we're very happy to say. But at the same time, when it comes to designs, there is still quite a lot of soul searching, and not everybody has committed to specific sort of architectures just yet. I think we're on the precipice of some of that, and certainly in the next year we'll see a lot more companies and a lot more projects committing to sort of specific designs and specific outcomes. Thanks very much.